All right, so they gave us this test and the no observation is given, but the inference SO2 evolved. All right, that means you need to know about SO2. So SO2, it will, anybody remember what is this hint for SO2? How did we?
Choking acidic.
Right, right. No, even though they don't mention it in the test, to confirm SO2, you're going to use, let's see. So if you want to confirm SO2, you're going to use potassium permanganate solution or potassium dichromate. All right. So since as they confirm it, it means that one of these would have to be used. So for my second observation, when the gas is produced, we would bubble it in KMnO4. So you could put KMnO4 is decolorized. Or dichromate change from orange to green. All right. So that is how you're sure that it would happen.
So
that it is SO2 for sure.
the overall charge on the manganate ion is -1, right? Minus.
Yeah, but so since K is on it, it cancels.
Yeah. And the overall charge on the Cr2O4, that is
2 minus.
2 minus.
2
so
minus.
When the manganate is reduced or oxidized.
It is reduced to plus. So the MnO4,
yeah,
it would go from this to this. So the potassium, it is reduced. It is +7 in this ion.
Oh.
Yeah. And chromium, it moved from +6 to +3. All right, so that's that. Next, the next test in the table now. So just all right, so the next thing that they said, shake M with water, then filter. So basically, you're add K2Cr2O7 let me put it as is. Add acidified Cr2O7 2 minus. So for this, so this observation would come down here. All right, so I guess up here could put that I guess is produced with a choking acidic smell, since as they follow up with the confirmation here. All right, so we're going to bring these So bring these down here. No, but you would still have to confirm it. So make it stay. All right, so this goes from orange. So what I'm going to do, switch this one. Oops, sorry that. So a gas was evolved, and we add that it has a choking acidic smell. And for inference, they have this sulfide ion is present. All right, so even though they split it up, right? Let me just explain what happened. What you really want to know is if sulfide ion is in the solution. How we confirm sulfite is the presence of SO2. All right. So if SO2 is evolved, it confirms sulfite is present. And as I was saying, you use the dichromate or the potassium permanganate to confirm it. All right. So once you use it and your sulfite is present, it means that you would have seen an orange to green color change.
So sir, but so you have
Yeah.
SO2, so you have SO3, 2 minus.
With SO4, you would have gotten a precipitate. So yeah, so with SO4, you would use, when it comes to SO4,
Which one of them are
and
SO4?
SO4, we would have reacted, we normally use barium nitrate or barium chloride. All right. And you would have gotten a precipitate of barium sulfate. All right. But the sulfite, it would not give you a precipitate. That is why we would need to confirm it by allowing a gas to be evolved. So we do this type of reaction to produce the gas to confirm sulfite.
So them two iron, they're the same iron. Now you have SO2 and you have SO3, so maybe I wonder.
For this, you must know the difference between sulfide and sulfate. Yeah, so these are the two ions for this section that you must know.
They have
Sulfide
SO2,
and sulfate.
You have SO2, SO3, SO4.
No man, this is sulfur. This is sulfur dioxide, a gas. This is the ion sulfide, SO3 2. So this is the gas. This is sulfide ion. This is sulfate ion. You understand? Or maybe I'm not. I am not
Yes, sir,
understanding.
Understand.
All right. All right. So the next one, it's with lead. So let me just do that quickly.
Yes, sir, for the sulfite, yeah. SO3, I use yeah, I get a choking smell. Yeah, the choking acidic. Yes, the sulfite.
Up here, just when you get the gas, not with the ion.
The dioxide. I'm the sulfide.
Right.
Sulfide. To I get orange green. That go decolorize the thing. Decolorize.
So if you yeah, so if you use if you use MNO, if it was MNO4 minus, then your observation would be purple to colorless. All right. All right. So
and the SO4, what the same change it give to?
No, the sulfate, you would get a white precipitate. So we would not need all of this for the sulfate. All right. because once you add barium chloride to the solution, you're going to get a white precipitate, and you know it is sulfate. All right. So the sulfate is easy. It is the sulfite that requires more steps. All right. All right. So basically, what they did next was to add potassium iodide in the next step. When they add potassium iodide, lead is, they said that lead is present. All right. Once lead is present, you will get a yellow precipitate as your observation. All right. So anytime you see potassium iodide, you are using it to test for lead. So if you use Ki and they told you that you got a yellow precipitate, you should know that Pb2 plus is present. All right. So Ki is used to test for lead. All right. All right. Quickly, I'm going to clear the screen and tell you something else quickly. So we are wrapping in 15 minutes. So let's take a picture. I'm going to clear the screen. All right. So quickly, halide ions. You're going to use AgNO3 followed by ammonia. All right. Chloride, you get a white precipitate, dissolves in dilute ammonia. All right. Bromide ion, you get a cream. So all you have to do is, sir, you know, in class, yeah. So the bromide ion, you get a cream precipitate. It dissolves in concentrated ammonia. All right. And iodide yellow, it is insoluble. All right, so it will not dissolve. So just remember those for your halogens. All right. I'm just going to quickly. Oh, in terms of half equation, they can ask you for half equations. What is going to happen is that these ions are going, the halide ions are going to combine with the silver ion to give you a silver chloride. Sorry, yeah. All right, which is a precipitate. So for these observations, if they ask you for the ionic equation, this is what you do. The halide ion with the silver ion. All right. If they give you lead nitrate instead of silver nitrate, it is the same thing. These halide ions will combine with the lead ion. All right, you will get PbCl2, which is a solid. All right. I'm going to erase the left-hand side. Here. All right, quickly again.
Sir, oh, you have Pb2 plus 2Br and get Pb chloride.
Come on, move fast. Sorry. Come on. Thanks. So it would be PbBr2. Yeah,
So chlorine is white, Cl minus is white, Br minus is cream, iodine is yellow. Now
right.
with ammonia, you get chlorine never dissolved in a dilute, Br never dissolved in a concentrated, and iodine is insoluble.
Insoluble, right?
Ammonia.
Yeah. Carbonate ion, a good thing I can tell, right? For this one, they will confirm it with a gas. All right. So when you're testing for, right? So you confirm it with CO2. So for the carbonate, confirm with CO2. How you know it's CO2? Once you see any observation that says turns lime water, which is calcium hydroxide, once it says it turns lime water milky, just know it is CO2. That is the only gas that is going to react with the lime water and turn it milky. It don't have to say milky, it can simply say a white precipitate. But once you say lime water, that is for CO2. All right, lime water is for CO2. The last thing on this I'm going to tell you. All right. And this, when it comes, is about 5 marks. So hopefully it's the ones you remember. All right. Once you use sodium hydroxide, you are testing for cations. All right, so Fe2 plus, green precipitate, green PPT, which other one? Copper, light blue, PPT, which other color you must know? Fe3 plus would be Fe3 plus, rusty brown. All right, for white precipitate now, right? This is where it comes into play. But for white precipitate, it can be aluminum, zinc, magnesium, calcium. What am I leaving out? Lead. I think I have it. Yeah, calcium, aluminum, magnesium, lead. Now, if the precipitate, please repeat.
Sir, Cr2 plus.
Cr, chromium is a transition metal. It would have a color. Check the color. Oh, barium is a white one as well. All right. That's supposed to have a color.
Sir, I thought barium
Yes?
does. I thought barium does. Sir, I thought barium doesn't give a precipitate.
Barium hydroxide?
Yes, sir.
Double check it for me. All right. All right, so just double check barium. I'm certain of these ones though. All right. So white precipitate, any of these, that is when you add it drop wise. All right. When you add sodium hydroxide in excess, if it dissolves in excess, you have zinc, aluminum, or lead. All right. So with sodium hydroxide, when you add a few drops, once you get a precipitate, any of these ions are present. When you add it in excess, if it dissolves, it is zinc, aluminum, or lead. All right, just remember that once it dissolves in excess, it is zinc, aluminum, or lead. All right, so continuing on now, you would move from sodium hydroxide and you would use ammonia. All right, if you get the white precipitate, just know that calcium does not form precipitate with NH3. All right. If you get, so the observation is the same for ammonia, just like sodium hydroxide. So I'm going to put the exception. Dissolve in excess. So continuing from zinc, aluminum, and lead, if it dissolves in excess, then you have zinc ion. All right. So if it dissolves in excess, it is zinc. That means if it does not dissolve, it is either lead or aluminum. And to differentiate between lead and aluminum, we do a confirmatory test. We do a confirmatory test for lead. All right. And so for that, we use Ki. All right. So once you see Ki, we are testing for lead. I know this part is a bit rushed, but hopefully some of it sticks. All right. All right. Let's just take a picture of the board. For iron, right? Hemoglobin. Hemoglobin, it contains Fe2+. All right. So I'm going to clear the board now. Take a picture.